This is a video about my Masso upgrade for my Shapeoko HDM. This is a view of my original HDM setup, which includes my enclosure as well as the computer up front and the controller in the back. I upgraded to Masso using the PWN CNC conversion kit. I also purchased their ATC. This video covers both the installation of the conversion kit as well as the ATC. There's three major components to the system: the pneumatics enclosure in the upper left, the VFD in the upper right, the electronics enclosure in the bottom, and then the braking resistor on the right. So I upgraded for several reasons. First off, I wanted to use an ATC who doesn't dislike doing bit changes, especially with metal. You've often got several bit changes, facing, roughing, finishing, chamfer bit. The next one was adding a rotary without having to slave my y-axis, which seemed like to be a pain in the butt. I wanted to use a 3D probe. I often work with round stock and want to be able to probe from the center of the round stock to find the hole. I wanted to use the pendant, although I may miss my stream deck, but I think the pendant will basically serve the same purpose. It's great to be able to manipulate the spindle with a device, right in front of it. And yes, you can use a gaming controller, but it seems like a pendant will work better. Z-brake, I'm very excited about that. I have broken several bits and gouged workpieces from hitting the E-stop in the middle of a job, and the spindle drops onto the workpiece, given the weight of the spindle, the 80 millimeter spindle. The gas strut seems like a bit of a kludgy solution to me. Closed loop steppers, I've never had an issue with the stock HDM steppers, but closed loop are supposedly better, so that will be an upgrade. And then finally, I'm looking forward to the dry run feature on Masso. I think I would like the reassurance of just, where the machine's going to cut. In addition to the conversion kit, the ATC, the tool setter, and the touch probe, there are 5 things you might want to buy from PWN to help make sure there are no delays in your installation. These are 4 NEMA 23 spacers, 1 squid, 1 top triggering proximity sensor, 1 thumbscrew, and an X Gantry LED light. The spacers are needed because the stem on the Carbide 3D steppers is very short compared to the PWN one. The PWN one is more normal, I would say. The spacers make up the difference. I milled mine in aluminum on the HDM before my conversion. I ended up needing 4 5mm spacers. Daniel from PWN CNC needed a 20mm spacer on his Z-axis when he converted, so your results might vary. PWN sells 3D printed spacers on their website. The next item that you'll need is what PWN calls a squid. They also sell this on their website. This is a combination of wires and resistors that delivers power to the stock Carbide 3D sensors, as well as the top triggering sensor that you would need to buy from PWN. This is the top triggering sensor that is available on PWN's website. You need this for the second y-axis because the stock HDM doesn't have a sensor on the second y-axis. Then you need a thumbscrew to go along with this sensor. This is what will trigger the sensor. It matches the one on the other side. I found the stem a little bit long, so I had to cut it down to be about 5mm. I just did this with a hacksaw. Finally, I bought the PWN X Gantry LED. This power cord should work with the existing LED. Customer support told me that too, and the Molex does fit, but it didn't light up. So instead of playing with that, I went ahead and just replaced my HDM's LED with this one. I ran into 2 little issues in the swap. Number one is it wasn't clear to where to cut the LED, because it does need to be cut to fit appropriately. What I ended up doing after a long search is I ended up just cutting it in a similar spot to the stock one, meaning the one from PWN, right, where it's currently cut. And that worked. Number 2 was that there's a little hole in the Y gantry that the Molex needs to go through, and that's a pretty tight fit. So I'd recommend installing the LED early in the process, once you've removed all the cables and before you add the new ones. That way the hole will be accessible. Next, let's discuss a big picture view of the system. Here are all the major components. On the left, you have the Masso controller, the back of it, which comes labeled from PWN. You have the 5 steppers in my case. I have one for a rotary axis as well. I don't go through that in this video though. You have what I call the electronics enclosure on the far right. It's labeled control in this diagram. You have the pneumatics enclosure on the bottom and the VFD on the bottom, as well as the spindle. Pwn has a really good video on how to connect the ATC. I'll link that in the description. Let's start with the steppers. The steppers have a cable. The cables are really nice. They're like 20 feet long, made of high quality wire. They're bonded together, 2 wires together. And as you can see on the steppers, there's 2 connectors. And then one cord goes to the power by the electrical controller, if you will, the electrical enclosure. The other one goes up to the controller. And you can separate those wires. Daniel covers this in his video, which is really nice. I separated mine about 6 feet because you could tell there's a good amount of distance between the back and the front of my machine, and that's what it needs to span. But it all went quite well, and I even have, extra length left over if need be. The only thing I was a little disappointed in is the control cable, which runs from the electrical controller up to the Masso controller, is only about 6 feet long. So I had to cut a hole in my conduit to make that connection work. That was unfortunate. So I'd recommend that Pwn make that cable a little bit longer, like 10 to 12 feet. I'm not going to go into the rest of these connections here. You can see them here as well. I wrote a document, installation instructions, if you will, where I also have pictures that I used. I also bought a label maker, which was invaluable. I labeled all my cords as I installed them. At the end of the first part, you'll see there was a rat nest of cords, and having them labeled was super helpful. The first step is to dismantle your current setup. Remove all the cables, remove the controller. This is also a good time to perform maintenance on your machine. I took this opportunity to replace some screws that had fallen out and lubricate my bearings as well as my ball screws, and also clean up aluminum chips that couldn't be reached with my normal vacuuming. Removing the stock spindle was easy. I just jogged the spindle down to rest on some gauge blocks and loosened the screws on the right, pulled it out. I had to wiggle the Pwn ATC spindle a little bit to get it to go through the mount. I'm using a 50 millimeter gauge block to rest it on. That puts it about 100 millimeters from the end of the spindle up to the spindle mount. I removed the stock steppers by just removing the 4 screws and wiggling it a bit and pulling. I initially tried unscrewing the screws on the coupler, but they were really hard to reach, especially on the Z-axis. So I think the wiggling off approach worked really well. Here you can see how small the stem of the stock stepper is. The Pwn steppers are really nice. They come packaged really well, and the Pwn logo is printed on them. The Pwn steppers are notably longer than the stock carbide ones, so make sure you check out the measurements on Pwn's website. This is the Z stepper. It also has a brake, which is phenomenal. I'm so excited about that. Putting it on was interesting, right? So I first started with the 20 millimeter spacer, but then I quickly realized that that didn't fit. It was too far away. And I was a little bit surprised. You can't see it in this picture, but that's what I'm trying to show. So I have the steppers. So I ended up using all 3 of the ones I made, plus I 3D printed another 5 millimeter one, and that is currently on my X-axis. I'll end up replacing that down the road. So by putting the 5 millimeter one, which worked fine, as you can see in this picture, the coupler seems to have nice spacing here. Moving on to the back steppers, you can see here how I wiggle it free with a little persuasion. Doing a freeze frame here so you can see how the stepper stem is flush with the coupler. You then move the coupler over to the new stepper, you put on the spacer, you re-wiggle it, if that's a word, back into the other coupling part, and then you stick in the 4 mounting screws and tighten them up, and you're good to go. Here are the 2 Pwn steppers on the Y-axis, all mounted up. You can see they look great. I don't go into connecting the cables here, but Daniel covers that in his video, and it's pretty straightforward. Okay, moving on to the proximity sensors. This is the location of the second Y sensor. So it already has a spot for it on the stock machine. You need a top triggering sensor from Pwn. and that is it installed. Pwn gives you 4 sensors with the machine, but they're not top triggering, so you need to buy one. This is the Thumbscrew. You'll need to bring that down to a 5mm stem so it sits flush. Pwn sells these, Amazon sells these, but nobody sells them at the 5mm. I also upgraded my drag chain. I bought this one on Amazon. I think it's 2 inches. I really like it, but I couldn't understand how to take off these covers, so I do a little video of it because it wasn't intuitive and it was hard to find information on it. So you just take a screwdriver, flathead, and you stick it in both sides and kind of pull it up. You have to do it a certain direction, and there's actually a graphic on there, and once you understand it, it's of a screwdriver, but it was hard to tell. So this is that drag chain, and this is after I've kind of connected all the hardware. Now I've got the controller there as well. I take a little tour around the machine. All the stuff is wired up. Oh, this is the stand I bought. I'll put all these links in the description. So the drag chain, you can see I removed all the stock stuff, and then the drag chain fits perfectly along the side. I've got a lot of pneumatic tubing going through this thing. I'm not sure if I'm going to do these cylinders that you see here. I ended up doing a 3D print mount instead, just to keep it more simple for now. And then you have the covers. You put the nose down first, and it snaps on, and then you have screws that go in the back. Again, Daniel covers that. You run the wire along the side, but they fit nicely. Just make sure you leave room within the cover for it to see the light. And here you see the resultant rat's nest of cords. I bought this cable labeler and used primarily the sticky ones. I didn't want to, take off the connectors, and this particular one I think only supports 3/4 inch. I also added this brush. This is from a master car. Ended up buying a longer one because I actually wanted it to brush along the tool rack there. So I actually bought a 6-inch one. Here's the various enclosures after the wiring, all the wiring. I chose to put the electronics one on the bottom because that has the most cords running into it. And then this is where you also can see where I had to cut a hole in the conduit. This is the conduit I bought. I really like this, fit well. The 2-inch one in particular fits all the cords that I needed to, and I was kind of concerned about that, but glad that worked out. I also did little zip tie things all the way in certain areas that worked well, and then everything runs back to the controller. The inlets panel is really also a great value add that from Pwn. Just really convenient. I've added, one thing. I'm probably going to add a few more things, but I really found that helpful. I'm now taking a journey around the left side of my machine. This is an enclosure that I built a while back, and then my pneumatics in the back. Right now, it houses the pneumatics for the solenoid for my mister, as well as the solenoid for my pneumatic dust boot. I'm showing the air lines coming in. I use a clone of the Max line stuff that's working well. This one here, the dryer is from Talons, if you will. It just crapped out on me. It was working great, but then developed a leak recently, so that sucks. But I get a new one on Monday. This is my setup outside my shop. I've got a 20-gallon compressor. It's a California Air Tools. It's doing well. I like it. And then it comes in through the Max line. I'm actually doing the first power on here, so there's 4 power buttons. Someday maybe I'd like to get this in the front of the machine, if you will. So, if anybody's done that, I'd like to understand a good way to do that, or maybe Pwn can develop something, but, maybe somewhere down the line, because I have to move a lot of stuff to get to the power, and I'd like to just do it from the front of the machine. Nonetheless, as people say, Masso boots super quickly, so that's pretty impressive. And now I think I'm going to go into some of the software configuration items. By the way, at this point in time, don't try to home your machine. You got to set up your steppers and stuff before you do that. So, but a great milestone to get everything on and everything working and no smoke. Before we move on to the software configuration, you should install the appendant. This is pretty straightforward. Marty Mitchell has a great video on it. Long story short, you just remove the housing of the DB15 connector, and you route the cable down out through the hole in the bottom, and then Pwn has a little notch in the back connector that you would put it through. As the last step in your hardware setup, I'd recommend tramming your spindle. So now we're into the Masso software configuration. First step, we're going to look at the proximity sensors. So this is where I found out I needed the squid. So you can trigger the sensors with a piece of metal, and they're already configured here, but you can see they're not triggering. They should go from low to high. So you need this thing called a squid. I ended up making my own. It's just a combination of some wires and some resistors, 5.6K ohm, I believe. The squid is the black one in the back, and that's going from the red power to the first 4 inlets on the far right, and these are doubled up. Moving on to the stepper configuration, this is one of the hardest parts for me. The first 2 fields in particular. The first field, distance per revolution, I had to resort to an AI search, but I got a good answer there, which was 10 millimeters. The second one, which is the pulses per revolution, what I didn't realize is on the side of the stepper, this table is published. So you look at your stepper and you look at the first 4 dip switches. And see the top, that little word says on. So up is on, down is off. So for my steppers, the right sequence is off, on, off, off, or 10,000 pulses per revolution. This value was set to 1600 when I received my controller from Pawn. So either they don't set that setting or someone did it incorrectly, which is understandable because if you were to look at the grid for 1600, it would be on, off, on. So someone could have easily just mistaken that or inverted that. So I'm not sure, but nonetheless, it was good to understand this. You should confirm your values on that screen. And by the way, when I tried to move my stepper with the pendant with that incorrect setting, it wouldn't move, which makes sense because that value is off by a factor of 10. You can find the values for the maximum feed rate and the maximum travel on Carbide's website. Although the video doesn't show it for this step, you would want to have a min of minus 145 and a max of plus 145. I'll explain that later. But this step here, you tap the wizard. This is helping you calibrate your steppers. To do this, you want to travel a known distance. So I'm using a 50 millimeter setup block, and I'm using my Heimer, and I zero at the top of the 50 millimeter block. In the wizard, you would click set 0. This is why you want to have your maximum travel set to positive 145, because when you hit 0, you wouldn't be able to go up if your max was 0. Because when you click set 0, it sets the machine to 0. So once you hit set 0, you want to jog the machine up a little bit so the Heimer probe clears the block, and then you remove the block, and then you jog back down to the bottom of the fixture plate and you zero there. And then you know you've traveled 50 millimeters, so the value you put into step 4 there is 50 millimeters. And then you hit calibrate, and Masso will change the distance per revolution value at the top to be more precise. So I did the same approach on X and Y. Here I'm using a Mitutoyo 300 millimeter ruler. In general, as you do this calibration, you want to use the longest distance possible. And this ruler is really nice. It doesn't have any slop on the ends, so it's exactly 300 millimeters. Again, use the Heimer, 0 on one end, go over 0 on the other, and put in the distance of 300 millimeters, and hit calibrate, and it will recalibrate the steppers for X and Y as well. If you don't have a Heimer, you can use a V-bit or a dial indicator. I've included screen captures of the configuration of each of my steppers. Notice I had to hit invert for a few of them as well. That's when they're going the wrong direction. Also a little bit of, and I also set the max value to 0 for all of them after I did the calibration. You can find the max values for the dimensions of your HDM on Carbide's website. You'll want to back off those values a little bit to give yourself a little bit of headroom. I did end up crashing my machine. I was following the Masso instructions, and Peter talks about running in MDI, run a X20, for example. So on my machine, X20 is on the other side of 0. And I thought the machine was in relative mode. Peter doesn't mention that. So make sure you set the machine in relative mode if you're going to test the movement via MDI. So you would want to run a G91 to put it in relative mode. Masso defaults to a G90 in setup, and so if you're not careful, it's going to try to move it to absolute value of X20, and that's what happened to me. So this view shows kind of the Cartesian layout of the HDM. The HDM homes and sets machine 0 to the far right, and it's got about 500 plus millimeters on Y and 600 plus millimeters on X. And so this just gives you, so all the values of the playing field, if you will, are negative, and that's why in your stepper setup, your max value is 0, and your min values are some negative value. From here, setting up homing is pretty straightforward. You go back to the F1 config screen, you go on homing, you go in steps, so I'm homing Z first. Then you'll go step 2, you're going to do X and Y together, and then B is slaved to Y. That's your second Y axis. There's a 5 millimeter back off. I set my speed to 1,000 millimeters to give me some reaction time. I later bumped that up to I think 3,000. But then you just say your prayers and hope for the best and hit home. I was really impressed of how quiet and gentle this homing sequence was compared to the stock HDM. This next one was a great find. My tool library in Fusion has about 100 tools, and Masso does not provide a way to bulk import tools from other libraries. However, this great user, Breezy, on Masso's forum has a post here. I'll link it, but it says, convert CAM tool libraries. It is an executable, so it runs in Windows. I happen to have a Windows machine, and I ran this, and it worked like a charm. So I was able to import my whole library. He supports not only Fusion, but also other software packages as well. So check it out. It worked really well. I'll walk through the screens here. Here I'm showing the output of the file. I'm showing my whole Fusion library. You see how it goes all the way up to roughly 100 tools. So that was super exciting. And the way that it works, you go to the last selection, the save and load settings. You export your current settings. That's going to create 2 files, one of which is a tool library file. You take that file and you run it through his executable program, and it will merge it, and you export your tools file from your program. It will merge a file together. You need to make sure the naming convention is all consistent or as expected, and then you load that back in, and then you reboot the machine. That's how it works. Setting up the tool changer was fairly straightforward. Daniel has a good video on this, so does Marty Mitchell. Basically, you just want to move your spindle into the position and then capture the different coordinates. You can do a screen capture of that. Then you enter that back into the tool changer configuration screen. You can see a copy of my settings here. The hardest part for me was what value to use for Z. As you can see, I got different measures. I took basically what I thought was a reasonable value, which was 127, and that seems to work fine. Here is a video of it running. I left the audio on. Hopefully I don't get flagged by the copyright police here, but I wanted you to be able to hear the tool change as well as see it. You can see a little bit of deflection, but I think it's okay. You can also hear a little bit of, I don't know, collision, if you will. I measured the holders at 28 millimeters, and I cut the holes at 28.5 to give it some clearance. Maybe I should have done more, I don't know, but it still seems to be working okay. We'll see. I hope this video helps other people with their migration. It may or may not be applicable to other machines in the HDM, but again, hopefully it helps. I'm super excited about the upgrade. Thanks for Pone for creating it, and hopefully it works well.